Imagine a world even more beautiful than our own, a place where the conditions for life are even better, more abundant, and far more diverse than Earth could ever hope to offer. It seems almost too good to be true, but thanks to the incredible advancements in modern astronomy, scientists have identified a new type of planet that might just meet these lofty expectations, the super-Earth. These planets are slightly larger than Earth, warmer, and orbit stars that live much longer than our Sun, giving life a much longer window to develop and evolve. Some of these planets could even be more habitable than Earth, offering us a tantalizing glimpse into the possibility of discovering a new home for humanity beyond our home planet. The discovery of these super-Earths has ignited the imagination of scientists, space enthusiasts, and anyone with a curiosity about the cosmos. The potential for a planet that offers the possibility of not only sustaining life but also fostering more advanced forms of life than what we have here is a captivating prospect. Could there be an inhabited super-Earth out there, thriving with species we cannot yet even imagine? And could one of these super-Earths offer a viable alternative for humanity, especially if Earth's future becomes uncertain? The possibilities seem endless, but as exciting as these prospects are, we must take a closer look at the real-world implications of these discoveries. Over the last few decades, our understanding of exoplanets, the planets that orbit stars outside our solar system, has grown exponentially. What was once the realm of science fiction has become a real field of study, with thousands of exoplanets discovered, many of which are located in what scientists call the habitable zone of their stars. This zone, sometimes referred to as the Goldilocks zone, is the region where conditions are just right for liquid water to exist, a key ingredient for life as we know it. Some of these planets, especially those known as super-Earths, have sparked intense interest because they have the potential to support life in ways that Earth cannot. The idea that there could be planets out there that are not just similar to Earth, but better suited for life, fires up the imagination. What if there were worlds with more abundant resources, more stable climates, and longer lifespans for their stars? What if these planets were more capable of supporting life forms that have had billions of years to evolve in optimal conditions, resulting in ecosystems far more complex and diverse than our own? Could life on these planets be more abundant and advanced than anything we could have imagined, filled with creatures and plants that we can't even begin to conceive of? These are the kinds of questions that keep scientists and dreamers alike up at night, staring at the stars and wondering what lies out there. One of the most important breakthroughs in the search for habitable exoplanets came in 2009 with the launch of NASA's Kepler Space Telescope. This extraordinary piece of technology was designed to detect exoplanets by measuring the tiny dips in brightness that occur when a planet passes in front of its star. These dips are incredibly small, but Kepler was able to measure them with remarkable accuracy, allowing scientists to detect planets that orbit distant stars. For the first time, astronomers were able to gather reliable data on the size, composition, and orbit of thousands of exoplanets, some of which were located in the habitable zone of their stars. The Kepler mission has revolutionized our understanding of the universe, providing us with information about over 5,000 known exoplanets, many of which fall into the category of super-Earths. These planets are typically larger than Earth, often ranging from 1.5 to 2 times the size of our planet. Despite their larger size, super-Earths are still small enough that they are not gas giants like Jupiter, and they may still have solid surfaces where life could take hold. What makes these planets particularly interesting is that many of them orbit stars that have a much longer lifespan than our Sun. Our Sun, a G-type main sequence star, is expected to run out of fuel and expand into a red giant in about 5 billion years, eventually rendering Earth uninhabitable. In contrast, K-type stars, which are cooler and smaller than our Sun, can live for up to 20 to 70 billion years, offering a much longer window of time for life to evolve on planets that orbit them. This longer lifespan could mean that planets orbiting K-type stars would have more time to develop complex ecosystems and sustain life. The fact that these stars are more stable than our Sun further increases the chances of a super-Earth being able to support life. On these planets, life could have billions of additional years to evolve, potentially leading to the development of more advanced civilizations. Imagine a world where life has had twice the amount of time to evolve, where species have adapted to conditions that are ideal for their survival. This could be the kind of world where life has reached levels of complexity that far surpass anything we have on Earth, with species that are more intelligent, more diverse, and perhaps even more resilient than anything we could imagine. One of the most promising candidates for such a super-Earth is a planet called KIC 983239, which orbits a K-type star called KOI 5715 in the Cygnus constellation. This planet is particularly intriguing because it is about 1.8 times the size of Earth, and it is estimated to be around 5.5 billion years old, placing it in a unique position in the search for habitable exoplanets. The star it orbits is a cool orange dwarf with a much longer lifespan than our Sun, which means that the planet could have had billions of years to develop life. The conditions on this planet are thought to be ideal for supporting life, with an atmosphere that could contain about 30% oxygen, which is much higher than Earth's current atmosphere. The average temperature on KIC 983239 is estimated to be about 5 degrees warmer than Earth, which could make it even more conducive to the development of life. The prospect of a planet with such ideal conditions is thrilling. A world with more oxygen, a slightly warmer temperature, and a much longer time frame for life to evolve could result in a biosphere that is more abundant, more diverse, and more complex than anything on Earth. Imagine a planet where ecosystems thrive in abundance, where new species are constantly evolving, and where the potential for intelligent life is greater than ever before. The diversity of life on such a planet could be astounding, with species that are more resilient and more capable of adapting to changing environments. Some scientists even speculate that life on this planet could be more advanced than anything we have here, possibly even with different types of humanoid species or creatures that we cannot yet imagine. However, as exciting as this vision is, it raises the question of how life on such a planet might differ from life on Earth. The larger size of KIC 983239 suggests that it has a higher gravity, which could have significant implications for the types of life forms that could thrive there. Life on this planet would likely need to be more robust and sturdy to withstand the additional weight pressure caused by the higher gravity. This could result in life forms that are stronger, with more developed muscles and bones to cope with the strain. If humans were to visit or colonize such a planet, they would likely feel heavier, and their bodies might have to adapt to the increased gravitational pressure. Over time, humans might experience stronger bone and muscle development, and our movement and reproduction might be significantly different from what we experience on Earth. This brings up the larger question of whether humanity could ever live on a super-Earth. The concept of human colonization of other planets is not new, and scientists have long been fascinated by the idea of sending humans to Mars or even farther out into the cosmos. However, the challenges of adapting to different planetary conditions are enormous. The lower gravity on Mars, for example, has already been shown to have negative effects on human health, leading to muscle and bone loss over time. The higher gravity on a super-Earth could present its own set of challenges, potentially making long-term habitation difficult for humans. It is difficult to say whether we would ever be able to live comfortably on such a planet without significant adaptations to our physiology or the development of advanced technologies that could help mitigate the effects of gravity. While the possibility of colonizing a super-Earth like KIC 983239 may seem far off, there is still a great deal of excitement around the potential for finding habitable exoplanets. One of the most promising areas of research in this field is the study of planets that are located in the habitable zone of their stars. These planets are in the sweet spot where the temperatures are just right for liquid water to exist, and they have the potential to support life. Scientists have also been looking for planets that are similar to Earth in terms of their size, composition, and atmospheric conditions. However, as exciting as these discoveries are, we are still a long way from being able to visit or colonize these planets. The distance between Earth and these super-Earths is staggering, with some of the most promising candidates located hundreds or even thousands of light-years away. For example, KIC 983239 is located around 2,964 light-years from Earth, which means that even if we had the technology to travel at the speed of light, it would take us nearly 3,000 years to reach it. This presents a huge challenge for any potential colonization efforts, and it raises the question of how we could ever get there in the first place. The idea of faster-than-light travel, which is still purely theoretical, has been proposed as a potential solution, but we are a long way from making it a reality. Despite these challenges, the search for habitable exoplanets continues, with scientists and astronomers eagerly scanning the skies for new discoveries. The James Webb Space Telescope, which was launched in 2021, is expected to play a major role in the study of distant exoplanets, including super-Earths like KIC 983239. With its advanced instruments and capabilities, the Webb telescope will be able to study the atmospheres of these planets in more detail, looking for signs of habitability such as the presence of water, oxygen, and other key elements that are essential for life. In addition to the James Webb Space Telescope, the European Space Agency's Plato mission will also play a crucial role in studying exoplanets. Plato, which is scheduled to launch in the coming years, will focus on finding and studying planets that are similar in size to Earth and located in the habitable zone of their stars. By studying these planets in detail, scientists hope to gain a better understanding of what makes a planet habitable and what conditions are necessary for life to thrive. The search for super-Earths and other potentially habitable exoplanets is an exciting frontier in science, and while we may not be able to visit these worlds anytime soon, the knowledge we gain from studying them could have profound implications for our understanding of life in the universe. Whether or not we will ever be able to live on a super-Earth is still uncertain, but the possibility that such planets exist, waiting to be explored, is a thought that will continue to captivate our imaginations for generations to come. As we continue to look outward into the vastness of space, one thing is clear: the universe is full of possibilities, and the discovery of a new home for humanity may one day be just a light year away.